This is the first lecture on Chapter 10, and this is going to be uh, um, looking at what happens uh, when an insured that has a policy or an annuity survives T years. So we know that they survive on the timeline to time T, and we want to determine what the company's liability is at that time. So that's going to be the discussion. Now, let's start back looking at this timeline here, and let's consider this level payment P shown on the timeline. It's at the beginning of each period, and this level payment is going to fund a liability that's going to be paid at time K. So time K is at the end here. I don't know if you can see that. Also, suppose that these payments are all certain to occur. So we're not talking about actuarial models now. We're talking about the class financial math because they're all certain to occur. So this is just a regular annuity of payments. And this is a liability that's going to be paid at time K. And this annuity is there to fund that liability. Okay, so how do we determine in that case what the payments PR that will fund the liability? One thing we can do is we can write down the equation of value from financial math, and the equation of value is that the present value of the liability equals to the present value of the payments. So the present value of the payments is just an annuity due for K periods times P. And that's equal to the present value of the liability. The present value of the liability is X times V to the K. So that's our equation of value from financial math. Now, if we rewrite this annuity due as an annuity due from time 0 to t, then we have to add to that a deferred annuity for this period of time. And so that's going to be deferred t years, and there's n minus t payments left in that second period of time. So we're just rewriting the left-hand side, and the right-hand side will keep the same. And now we're going to multiply both sides by 1 plus I to the t. So one term on the left side is going to be 1 plus I to the t times that annuity due for t payments. The second is going to be p v to the t 1 plus I to the t times the annuity due for n minus t periods. And the right-hand side is x v to the k 1 plus I to the t. Okay, well, the first symbol here turns into the accumulated value symbol, right? When you multiply by 1 plus I to the t, this becomes st. Got to put the umlaut above it. And in the second symbol, v to the t, 1 plus I to the t cancel each other, and I just get annuity due for a period of n minus t. And then the right-hand side, I use the laws of exponents, and I get x v to the k minus t, because 1 plus I to the t is v to the minus t power. Okay, so if I now subtract the second term to the other side, then the left-hand side is the accumulated value of the level payments that are funding the liability that has to be paid at time K. So that's the accumulated value of the payments at time T. The right-hand side is an expression showing the liability at time T. Now, why is it the liability? Because it's the present value of the amount that we're going to have to pay at time K minus T. So that's money out, and we're subtracting the money that's going to come in during that time, which are the payments P, the remaining payments P for funding it. So this net effect is money out, and that is the net liability of the company that has to pay liability at time K. Now we want to do the same thing, only we want to do this taking into account probabilities of these events occurring. In other words, they're contingent upon some event like death. So the benefit is the contingent payment. So that's going to be the liability to the issuing company. That's going to be the liability to the life insurance company. You have the benefit as a life insurance benefit. The net premiums are going to be the contingent funding payments for the benefit. And the teeth terminal net premium reserve, that's a mouthful, that's the term that we want to define, is going to be the actuarial present value of future benefits minus the actuarial present value of net premiums. We see the analog up here from financial math. This is the present value of the future benefit to be paid minus the present value of the funding payments to be received. So in a contingent setting, the present values turn into actuarial present values. This teeth terminal net premium reserve is denoted by this new notation where we put T in the subscript before the V, and the V is the symbol that we use for this liability. So it is the liability of the issuing company given survival to time T, survival of the policy. So here's our assumptions. The net level premium, denoted NLP, they're determined by the equivalence principle. We're going to see that over and over again. So we've already seen that in the funding chapter in the book, but we're going to do it many times throughout this chapter. We're going to use the same life table and interest rate in calculating the terminal reserve that we used when we determined the net level premium. So if these assumptions hold, then the reserves are called the net level premium reserves, or NLP reserves. So for example, this is kind of the most basic example that we always start out with. We have 1 unit of whole life. It's issued to X. The benefit is paid at the end of the year of death, and it's funded by the standard level premium that we denote by p sub x from the equivalence principle. If X has survived to age X plus T, then let's write down what the T net level premium reserve should be, a formula for it. So let me draw a timeline first. For age X here, X has survived to age X plus T. And so we're right here presently. And what we want to do is calculate the company's liability on this policy. So it's going to be money out minus money in. So first I need to calculate my premium. So this is determined by the equivalence principle, so I can immediately write down what my premium is. So that's my level premium payment. So what's the actuarial present value of the $1 whole life policy? Well, now I'm age X plus T, so the actuarial present value is a whole life issued at age X plus T, minus the actuarial present value of the premiums of future premiums. Well, I'm paying this premium here that was determined at issue, and I'm now age X plus T, so it's a life annuity due issued at age X plus T, and the amount of that payment is the same premium payment I've been making since the policy was issued. So this is a formula for the teeth net level premium terminal reserve on that $1 whole life policy. Okay, let's take another example. Let's look at in-year term insurance. So, in-year term insurance, if the policy is still in force and I have survived to age X plus T, and the policy is going to mature in years after issue, I'm right here. I'm during, it's still during the contract. When the contract expires, there is no liability, so obviously we want to have T less than N. Well, the equivalence principle tells us that this is just the actuarial present value at issue of one-year term insurance, of in-year term insurance, divided by the temporary life annuity due with term N. And so that's my level premium payment. So this is a premium payment I'm going to be making. Now I'm right here at time x plus t. I've survived t years. This is the symbol for that Tth terminal reserve. You see in front of the V I have the 1 year term life symbols. And then to the left of the V I have T, indicating that I have survived, the policyholder has survived T years, and we're doing the calculation at the end of year T. So, what's the actuarial present value of future benefits? Well, benefits are going to be paid in here if death occurs. So that's just going to be term insurance issued to someone age X plus T, and how much time is left? N minus T years. So that is term insurance issued to age X plus T, and there's N minus T years remaining. So that's the actuarial present value of future benefits minus the actuarial present value of future premiums. And the premium payment that I've been paying all along is still the premium payment I'm going to pay, but now I'm age X plus T, and there is N minus T time left in that temporary annuity period. So it's the temporary annuity, actuarial present value of the temporary annuity issued to age X plus T with a period of N minus T years remaining. So that's what the Tth year terminal reserve looks like for in-year term insurance. Okay, let's look at limited pay insurance. So H-pay whole life. So H-pay whole life means I'm going to pay the premium for H years, and that's all, and then the whole life policy will continue for the rest of my life. So 1 unit of whole life issued to X, benefit paid at the end of the year of death, funded by this premium determined by the equivalence principle. If X has survived to age X plus T, then the T net level premium terminal reserve is, okay, so I go through the same process. First I calculate the premium payment. So the level premium payment, let's see, it's whole life issued to age X. And now there are H payments, so it's annuity due, or temporary annuity, life annuity due with a term of H. Right? H year term annuity due issued to X. Temporary annuity due issued to X. So that's my level payment. Case 1. If we're during the premium paying period, so I'm still paying premiums, actuarial present value of future benefits, again it's a whole life policy, so that's easy to write down, minus the actuarial present value of future premium payments. Well, I'm paying this premium payment, and how many of them do I have left? Well, I have H minus T of them left if I'm during the premium payment period. I'm age X plus T, and so that's my temporary annuity due symbol, just to show you what I did here. Actually, T is less than H, right? So I'm here, I'm still in this premium paying period, but the amount of time left is only H minus T. That's the amount of time left. So this gives me the actuarial present value of future premiums, and then premiums stop, but the policy continues. It's a whole life policy. Now, if H happens to be less than T, so that the premium period has now ended, here's the premium period, and I've survived to this point in time, there are no future premiums to pay. So that's just the actuarial present value of future benefits. Notice when I have a limited pay policy that I've come up with this special notation, or the actuaries have this special notation where they put the limited pay period as a superscript on the back side of V. Okay, well sometimes it's useful, especially when one is first learning about reserves, to calculate them near the end of certain contracts, and that seems to bring to light, the meaning maybe a little more clearly as to what we mean by the liability at a certain time. So for example, if we have in-year term insurance, this symbol tells me I want the terminal reserve in years after issue on an in-year term insurance contract. Well, you're trying to find the company's liability at the time the contract expires. But since the contract expires and it's a term life policy, the company's liability is zero. So that terminal reserve at the time the contract expires is equal to zero. So how about if we back up a year and think about it? Well, if we back up a year, then $1 of benefit will be paid if death occurs in the next year. So the probability of death occurring in the next year is going to be the Q, right? Q x plus n minus 1. And the $1 has to be discounted back 1 year. It's going to be paid at maturity if death occurs in that time interval. Also, we have to subtract the actual present value of future premiums, and we have exactly one premium payment left, and that premium payment is going to occur just right after I calculate this liability. So it is the 1 year term premium. Excuse me, the in-year term premium. But I only have one of them left to pay, and it's being paid right here. And I pay it just after, the moment after I calculate this. Okay, let's look at in-year endowment insurance. For in-year endowment insurance, when I'm at the end of the policy, I've survived to age X plus N, the endowment benefit of $1 is paid if I survive to age X plus N. So that's my liability, that endowment benefit. If I back up 1 year, so that I survive to age X plus N minus 1, that will be the terminal reserve at time N minus 1. Well, this $1 is sure to get paid. If I die in here, in the next year, the $1 gets paid as a benefit to my beneficiary. If I survive to the end of the policy, the $1 gets paid to me. So either way, the company is going to have to pay $1 here. It's a sure thing. So the actuarial present value of that benefit is just the $1 discounted back 1 year. And of course, I have to pay one more premium just after I calculate this terminal reserve. So that's my premium from the equivalence principle on that in-year endowment policy. Okay, so hopefully looking at these liabilities near the end of the contract has given you a little bit better understanding of what they mean. But to go through a numerical example might also help you. So let's look at this example where we're going to look at a 3-year term policy issued to age 45. Okay, 3-year term issued to age 45. Well, first of all, you can calculate the actuarial present value of that 3-year term policy. You should be able to confirm this number from this table. Now, how are you going to confirm that number? You're going to take what? 3-year term, V Q45 plus V squared P45 Q46 plus V cubed P45 2, Q47. That's your 3-year term formula. You should be able to write that down from memory now. But plug the numbers in and confirm that this is the actuarial present value of that. Now, the temporary life annuity due of 3 years issued to age 45. Let's remind you what that is. So it's life annuity due. There's my $1 at time 0. This is my VP. V, P45, 0.93, 1 minus 0.07, plus what? V squared, 1 over 1.03 squared. Now I need P45-2. The P45-2 is I multiply the probabilities of surviving 1 year and the probability of surviving the 2nd year, and that's the probability of surviving 2 years. So this is my P45-2. And this is my 3-year temporary annuity. So if I do that numerical calculation, I get 2.69. So don't forget how to do these numerical calculations that we've already done in the past. We need to be able to continue to do them. So here's my premium from the equivalence principle. It's just going to be my actuarial present value 3-year term divided by this temporary 3-year temporary life annuity. So it's going to be my 0.2552 over 2.69. Okay, so there's my level premium. Now I want to calculate my terminal reserve given I've survived to age 46. Right, that's what that means. This is the terminal reserve 1 year from issue. So it's the terminal reserve right here. So the actuarial present value of future benefits is just going to be 2-year term insurance issued to age 46. So minus the premium, the level premium I just calculated, and it's going to be a 2-year temporary annuity due issued to 46. Okay, so let's see. Let's calculate the 2-year term insurance first. So it's going to be V Q46, which is 0.1, plus V squared. So I have to survive to age 47 and then die. Q47.13. So there's the actuarial present value of my 2-year term insurance. And I have to subtract my premium, which is 0.09487, times the actuarial present value of my 2-year temporary annuity due, 1 plus V times P. Okay, so now all you have to do is arithmetic. Do that arithmetic. There's your 1-year terminal reserve. And what's your 2-year terminal reserve? So that tells me that we're calculating it. I'm age 47. The insured has survived 2 years. And there's only 1 year left in the policy. Okay, so we're to that case that we had a while ago. We're going to discount the death benefit back. The probability of receiving the death benefit is if we die in the next year. And the premium, we're going to receive the premium just after we calculate this terminal reserve, and there's only 1 left. So if we fill in those numbers, I get V, Q47, and the net level premium is 0.09487. So my liability at that point, my teeth net level premium reserve, 0.03134. So these little numerical calculations I think are good because they do review a lot of the simple calculations we've learned that we need to continue to be able to do. And they also illustrate the new concept of calculating the terminal reserve. Okay. Let's see. Let's derive a few identities from the MIIs for the terminal reserve. The first identity is just for the T terminal net level premium reserve for whole life issued to Ajax. So here's my formula: actuarial present value, future benefits minus actuarial present value, future premiums. And I just replace the A, the capital A, with its equivalent formula from the MII. Remember, the MII is this. And so if I just solve that for capital A, x plus t, I get what's in parentheses. I can then factor out the A umlaut x plus t, and when I do that, I get what, 1 minus px plus d times life annuity due hx plus t. Okay, now back when we studied funding, we showed that the equivalence principle led to this identity. So if we substitute that in, I get 1 minus, and then px plus t is a reciprocal of a life annuity due issued to Ajax. So in other words, this becomes our first identity. Or you could call it our second identity, but this is mainly just for deriving the rest. Okay, now we substitute that premium formula that I circled in for both the numerator and denominator. What do I get? I get 1 minus, and then I'm going to substitute in 1 over, let's see, ax plus t, see, life annuity due issued to Ajax plus t is 1 over px plus t plus d, and then the denominator is 1 over px plus d. Now take reciprocals and multiply. And then I get a common denominator of px plus t subscripted plus d. And my d's subtract away. If that's a little bit too quick for you, just go back through those calculations. And this is the second identity involving net level premium formulas calculated using the equivalence principle. And finally, if we go back up here to this identity, and we replace each of the life annuity dues with their MII equivalent, then I have what? 1 minus ax plus t over d divided by 1 minus ax over d. Now I invert and multiply. The d's cancel. Now I get a common denominator of 1 minus ax. So I have to multiply the 1 by 1 minus ax over 1 minus ax. And the 1's are going to subtract away, and the ax plus t becomes positive. And so here's yet a third identity for the terminal reserve for whole life issued at Ajax at the end of your policy year T. Okay, so we have 3 basic identities, one involving life annuity dues, one involving the net level premiums, and a third one involving the actuarial present value of the insurances at Ajax and X plus T. In your homework, you're going to be using the MII to derive similar identities for endowment insurance. So you're going to come up with, if we count the very first one as an identity, you're going to be coming up with 4 identities for in-year endowment insurance using your MIIs, just like we did in this case. So on page 264, exercises 1 through 5, you should be able to do those now from what we've talked about in this lecture. If any part of the lecture went too fast, you should go and look at it again and review it, and review your book. Again, I've done different examples in your book, and maybe left some of the book's material out, but I'll cover this pretty thoroughly when we do some lectures in class as well. Okay, good luck on the homework.